So in this video, we're going to look at rational functions again, but we're looking at graphs of the form f of x equals ax plus b over cx plus, and looks like we forgot our d. Cx plus d. Okay, so let's have a look and see what we're graphing today. So we're asked to graph the following function. F of x equals x squared plus x minus 12 over x squared minus 4. So the first thing we want to do is we want to factor this. So let's factor the numerator and the denominator. So in the numerator, we can factor this. Factors of 12 are 4 and 3, 2 and 6, 1 and 12. So it looks like 3 and 4 are going to prove useful. Okay. So we have 4x minus 3x and gives us our x, our 1x in the middle. In the denominator, we have x squared minus 4, which is the difference of squares. So it factors as x minus 2 times x plus 2. Okay, so now let's consider the x-intercepts. How do we find the x-intercepts? We have to set f of x equals 0 and solve for x. So f of x equals 0, solve for x. And we get x equals -4 and 3. The y-intercepts, we let x equal 0. So we solve f at 0 and see what we get. And what do we get? When we get, in the numerator, you get 4 times -3, denominator -2 times 2. And what do we end up with? Yes, we end up with 3. That's our y-intercept, y equals 3. And vertical asymptotes, our vertical asymptotes occur when our function's undefined. And that occurs when the denominator equals 0. So our vertical asymptotes are when x equals 2 and x equals -2. Our horizontal asymptotes, these occur when the x values go off to infinity in the positive direction and the negative direction. So we're going to look at the limit as x approaches let's positive or negative infinity of our function. Let's use the unfactored form. Okay, let's scroll up and give ourselves a bit more space. Okay, so we're again, limit as x approaches plus or minus infinity. We're going to divide each term by x squared. Okay. Whoops, this. Right. Running out of space. Let's make this a bit smaller so we can fit it all in. And similarly, in the denominator, we factor out the x squared. We're left with x squared times 1 minus 4 over x squared. So now, when we take the limit and let x go off to plus or negative infinity, well, I guess the first thing we do before that, we can cancel out our x squared. Okay. So, okay, let's get one more step. Limit as x approaches positive or negative infinity. In the numerator, we have 1 plus 1 over x minus 12 over x squared. In the denominator, we have 1 minus 4 over x squared. As x gets very large, all these terms I'm crossing out tend to 0, and we're left with 1. So therefore, our horizontal asymptote is y equals 1. All right, so let's put some boxes around some of these things so we know what information we need from here. And our x-intercepts, our x equals -4 and 3. We have our y-intercept vertical asymptotes, horizontal asymptotes. Let's consider our domains. It's nice to have that. Our domain, the set of all x values in the real numbers, such that only time the only time we're not able to attain any of the real numbers is when we have an asymptote. So x is a real number except -2 and 2. And our range, similarly for a range is y is a set of all real numbers except when y equals the asymptote, which is y equals 1. Good. All right, so now we need to determine when our function, let's scroll over to the right, is positive or negative, so the sign of our function. So now we need to consider our table. All right, so let's look at our real line or number line and divide it up. Okay, so we have our X-Intercepts. Let's see. Yes, that's right. -4 and 3. And then we have our vertical asymptotes, when x equals -2, x equals 2. And these points are going to create our intervals on the real line. So when x is less than -4, x is less than -4, x is between -4 and -2, x is between -2 and 2, x is between 2 and 3, and x is greater than 3. So these are our intervals. Let's put our factors for a function along the side. We have x plus 4, x minus 3, x minus 2, x plus 2, and then finally our function f of x is a product and quotient of all these factors. Okay. All right. So now we have our table. And let's see what's going on these intervals. So x plus 4 is negative. Let's see, positive. Okay, good. X minus 3, negative. What do we have here? Negative. Good. And then x minus 2. Good. Let's see. And you can check these as well on your own. X plus 2, negative, negative, positive. Okay. So I think we're good. So now we're going to look down the column, and we have, on the first column, we have 4 negative signs. So when you take the product and quotient of these 4, we end up with a positive. Second column, 3 negative signs. Product and quotient of 3 negatives gives us a negative value. 2 negatives, product and quotient of 2 negative values gives us a positive. 1 negative, we get a negative, and finally all positive, and we get a positive. So now we know the intervals on which our function is positive and negative. I think we have enough information. We can graph our function now. So let's draw some axes in. I think we have enough space right here. Let's put our axes in, and we'll start drawing. Nice straight lines today. Okay. So next, let's put in, so we have our x and y axes. Let's put in our asymptote. So we have an asymptote when x equals -2, another one when x equals 2. Those are vertical asymptotes. And then, of course, we have a horizontal asymptote when y equals 1. All right, so let's put some labels in. Y-axis, x-axis, our horizontal asymptote, vertical asymptotes. Let's put our our X-Intercepts in, -4 and 3. Okay. Do we have a Y-intercept? Yes, we do. Our Y-intercept was 3. That's right. And now let's graph. So remember, on the interval when x was less than -4, I believe, when x was less than -4, our function was positive, and between -4 and 2, it was negative. So the function probably looks something like this. Whoops, not so pretty. Let's try that again. So again, we have our our asymptote of y equals 1, and then on the interval from -2 to 2, our function is positive. So it probably goes up something like this. Then we have our asymptotes at x equals -2 and 2. And then finally when x is between 2 and 3, our function is negative. And then when x is greater than 3, it's positive. And we have our two asymptotes. Our function probably looks something like that. So this green curve, all these green pieces, make up our function f of x equals x squared plus x minus 12 all over x squared minus 4. Good. That's our first function. All right, so do we have another one? Yes, we do. Okay, so let's have a look at this one. Y equals x minus 2 over 2x minus 1. So we want to graph this. So again, what do? So it looks like it's factored, so we don't have to do that. So let's find our x-intercept. Our x-intercept is pretty easy. So that's when our function y equals 0, and that occurs when x equals 2. Our y-intercept occurs when we set x equal to 0. When we do that, y equals, looks like y equals 2 as well. That's easy. And then our vertical asymptote occurs when our function is undefined. That occurs when the denominator equals 0. So when 2x minus 1 equals 0, or when x equals 1/2, that's our vertical asymptote. Our horizontal asymptote, let's take the limit as x approaches positive or negative infinity of our function, x minus 2 over 2x minus 1. Okay, we're going to factor out the x in the numerator and denominator. Let's see what happens. Okay, we can cancel out these x's. And we're left with the limit as x approaches positive or negative infinity of 1 minus 2x over 2 minus 1 over x. The 2 over x goes to 0, and the 1 over x goes to 0, and we're left with 1 over 2. So therefore, y equals 1 over 2 is a horizontal asymptote. Good. Okay, and our domain, let's figure out what our domain is. Our domain, again, x is a set of all real numbers such that, so the only value x cannot equal is 1/2, because this is where we have our vertical asymptote. Our range is a set of all real numbers except when we have our horizontal asymptote, which occurs when y equals 1/2. Okay. So what else do we need? We need our intervals of, we need the intervals when our function is positive or negative. So let's take our real line and divide it up. So points of interest are 1/2. And what else do we have? 2, I believe. Yeah, so when x is 1/2, that's when we have our vertical asymptote, and 2 is our x-intercept. So our intervals are when x is less than 1/2, when x is between 1/2 and 2, and when x is greater than 2. So we have 3 intervals here. Okay. Let's put our factors, x minus 2 and 2x minus 1 in. And then finally our function, x minus 2 over 2x minus 1. That's our function. Let's have a look at the values of our factors on these intervals. So let's see. So x minus 2 is negative when x is less than 1/2. Negative when x is between 1/2 and 2. Okay, that's not right. When x is greater than when x is greater than or equal to 2, x minus 2 is positive. So 2x minus 1 is negative when x is less than a half, positive when x is between 1/2 and 2, and positive when x is greater than or equal to 2. So I guess we can choose there. X is equal to 2 on only one of these intervals, not both. And then finally, our function x minus 2 over 2x minus 1, if we look down the column, when x is less than a half, our function is positive. When x is between a half and 2, it's negative. When x is greater than 2, it's again positive. So it looks like we have all the information we need. Now let's graph our function. Let's scroll over to the right and put all this information together. We'll draw our axes in. These are nice straight lines here. Okay. And let's put our vertical asymptote in. We have our vertical asymptote in at x equals a half, our horizontal asymptote of y equals a half. Good. Now let's label our graph. We have our axes, x and y, vertical asymptote, horizontal asymptote, and our X-intercept. Do we have a Y-intercept? Yes, we do. Y equals 2. Let's just check that. Did we find that? Yes. Our X-intercept is when x equals 2. Our Y-intercept is when y equals 2. So we're going to include that information in. So I think we have all the pieces we need. Now we're just going to join the dots. All right. So on the interval from negative infinity to a half, so when x is less than a half, our function is positive, and we need to go through the point y equals 2. So that's our y-intercept. So our function looks something like this. And then when on the interval from 1/2 to 2, our function's negative. So it probably looks like this. And then when x is greater than 2, our function's positive. So it looks a little like this. Okay. So these green pieces make up our function f of x equals x minus 2 over 2x minus 1. And that's the graph of our function. So that brings us to the end of our video today. If you have any questions, send us a note at info@raisemymarks.com or give us a call, day or evening. We look forward to hearing from you. Thank you for watching.